Hello everyone, my name is V. Now I will present about my research on dipterocarpal derivatives. Our talk will be divided into four parts. The first part is some current problems that I will research. As you may know, that ginseng has derived from Korea with many benefits to our health. However, the big disadvantage is high price for lower class. One more recent problem is the polymeric missile used in designing drug delivery system has a high score when we use cholesterol in that complex structure. Therefore, we decided to find alternatives that can replace the cholesterol and the ginsenoside with an affordable price, and this is dipterocarpus. The compound extracted from Dipterocarpus alatus run along the Kulon River. As you can see on the slide, the similarities in some part of dip with the other two that proves its potential replacement. However, due to the hindrance structure and the less research about this structure, so we decided to increase the solubility of dip and find alternatives to cholesterol in the complex of PEG cholesterol. The flowchart displays main procedure in our research. For isolation of dip, we use MMR to analyze the obtain structure, and we compared that result with the one released by the sigma. Due to the huge slot during workup state, our use was only troublesome. We then synthesized lactose using grown outside, and the power obtained went through the NMR too. The only different part from the deep structure was the side chain. So the red part represents for hydrogen in the electron ring. Next, we reduce the group in the ring A of dip into your stroke, and this shows clearly on the MR result at the red part. We also perform the reduction at the same position using in the lactone using the same procedure, but the U was slow during purification state. We then transform the OH group in the lactone to an alkene group, but due to the semi-oil form, the U was not high, and it was easily deradable in the air. The hydrogen at the double bond show clearly in the ML result. Finally, we will take one more hydrogen group into that double bond by using MCBBA. Because of the semi-oil of the reactant, the compound degraded a lot during the reaction that make the U low. The MR showed that there was a change in the signal at around 7.5, which was hydrogen on the MCBBA ring, and about 2.5 at the hydrogen near the MCBBA ring. This is the CMR result. It is also a PEG part. After obtaining alcohol derivative, we replace the OH group with the succinate group, and the signal at around 2.5 percent hydrogen on succinate chain. After that, we obtain a PEG into the succinate position, but the PEG 400 had too many byproducts that we cannot isolate it. Our wanted compound, we apply the same ratio for PEG 1000, and it gave an NMR which was shown in the slide. The highest peak was PEG 1000 group, and the hydrogen on succinate chain was also displayed. So we successfully synthesized substituted compound to cholesterol and resolvability to the original dip, even the yields are not high. Therefore, we need further research on finding other catalysts that can boost up our yield, and we also need to perform more antimicrobial, anti-cancer tests to evaluate the bioactive properties of our compounds. Thank you for listening.